Hello, guys. Good evening. I hope everyone is doing good today. So, today we are going to continue on our data engineering series. And before we get to our video, I would like to introduce about our company. We are Data Valley, the fastest growing edtech company of 2025. And if you're wondering what do we do as a company, we provide you with IT solutions, trainings, and placement support as well. So, what do I mean by IT solutions? Let's say you have a company and you need a talent pool of people who can take over the job from day one. Yes, we do have people who can take over the job from day one because we have a multiple skilled, talented people, professionals who are always ready for these kind of scenarios, and we provide you service for your company. So for your company, if you need a talent pool of people, yes, we support in that. But what about others? What if I need a training support? What do I need to learn about hottest technology in the industry now? Yes, we do provide you with training support as well. Talking about training, we provide trainings in multiple subjects, and these trainings are provided in multiple modes as well. So we have live classes, we have online classes, we have YouTube live streams, like these kind of knowledgeable contents getting shared. So we have multiple modes of learning as well. So if you would like to have a glance about what we do, how we do, and how these trainings are provided, and how we support you in your career, you can please check it out at our website at datavalley.ai. And talking about training, here are the few hottest subjects that we teach: data engineering, data analyst, data science, ethical hacking, cybersecurity, network engineers, SQL developer, Python developer, UI UX designer, software engineer, MERN stack developer, web developer. So all these kind of hottest role in the industry right now is being taught in our institute. So please do have a look in on that perspective in our website, so you'll get a good idea about how you can take your career further forward. And not only that, when you enroll for a training, your learning journey doesn't just end there when you finish your course, but you also get 100% placement assistance. So all your training preparations, the training materials, uh, your the job vacancy available list. So all these kind of provisions will be provided to you, and you can with your efforts, all the knowledge you have gathered from your trainings, you can just employ there, and you can get your job wherever you choose to go. So good luck with that as well if you're part of Data Valley. And I see that a lot of people from different community as well have joined in here. So I wish you all good luck to learn a lot of from this data engineering session. And not only that, if you like this video, feel free to give a thumbs up and click the bell icon so that you don't miss out on the regular updates. And if you have any questions, feel free to drop your questions in the comment section, and I will definitely address it either in this session, and if I miss it out, either me or my teammates will address to you in the comment section. All right? Okay. And myself, Franklin, I've almost got 3+ years of experience as a data engineer. And as I say always, this is from an experience perspective, and this is not just one person's viewpoint, but it is like all my friends, network of professionals who are going for data engineering interviews, what is being asked in the interviews and how do you face it. And these are more like scenario based rather than just learning it for the sake of just the knowledge, but these are more scenario based, and this will really help you. And feel free to share it with your friends who are trying to be data engineers as well, who are trying for the interviews. And one more thing I must say is that you might be a fresher, you might be from a college, or you might be intermediate professional with 2 to 4 years experience, or you might be a senior professional with like more than 5+ years of experience. If you ask me, can you join in this session? Yes, you can, because this is where we are going to brush up the skills. So if you have no knowledge about anything, don't worry, I teach from the scratch. But if you already know about it, don't worry, this is still about brushing up your knowledge and skill with all the latest and updated information. Okay. So let's jump to our video now. And today we are starting with our data engineering part 15. So what is this part 15 going to about? This data engineering series 15 is going to be about AWS Glue again. You might be wondering, haven't I taught you all AWS Glue in the previous 4 classes? Yes, I have taught you uh, data engineering AWS Glue concepts in previous 4 sessions. But how is this different? This is different in a way that I've already explained in the previous video as well. We started from what is what, and now we have jumped to a position where we discuss about scenarios, we discuss about how things are getting done, how we improvise the performance, how do we do optimization of the already working pipelines. So this is what the levels that we are climbing up to, right? And if I'm teaching something in depth, if you have to know something in a broad fashion, your learning just doesn't end in like few hours, right? It needs a lot of compilation of different scenarios, different use case scenarios, and how do you deal with it, what is the industry optimal standards that is in place. So we must discuss all these kind of standards so that you will be able to talk about all these in your interviews. I think I make sense to you, right? So this is the fifth video of this Glue series, and today we'll be talking about the performance. Okay. The first question that we have here is, what is the difference? Oh, sorry. Yeah. What is the difference between AWS Glue Studio and Glue Data Brew? So, before we jump to that, if you have been following our previous videos, I mean, I recommend you to follow that, but still, this is a standalone video and you can still continue with this. And I've asked a simple question: what is the difference between Glue Studio and Glue Data Brew? I believe you all would have got confused here. Why? Because you know that Glue Studio is where you use the visual interface to design your pipeline, right? And what does the Glue Data Brew do? It still uses the visual interface, and we prepare our data, but still it's a visual interface. And there is a pretty much a linear line between Glue Studio and Data Brew, where their purpose, their features, their focus point, the advantage they possess, they all differ. Okay, but they all can be used in a combined fashion as well. So, to go by the idea of definition, AWS Glue Studio is a visual ETL service for building, running, and monitoring end to end data pipelines. While AWS Glue Data Brew is a visual data preparation tool focused on cleaning, normalizing, and enriching data with no code transformations for data analysts and data scientists. Yes, you're right if you just thought about the Glue Studio as a visual interface tool to design the ETL. But how is it different to the Data Brew then? So in the previous video, we learned about creating recipes, right? Recipes are nothing but a sequence of transformations. So you create recipes in your data brew with which you prepare your data as well. So the primary purpose of Glue Studio is to build, run, and monitor the data pipelines. Whereas the Glue Data Brew is used to clean, normalize, and enrich the data with no code transformations. Okay, so you're not going to use any codes. It's still a visual data preparation tool, so you'll have a visual interface which you'll be using to clean and normalize and standardize or enrich your data. Okay, and this is mainly used by data analyst and data scientist. And there is one key thing I would like to address before we see the differences in deep. Recent integrations allow us to use the data brew transformations within the Glue Studio's visual job editor. So we all know that Glue Studio has a visual interface. So within that visual interface, or you can call it the visual job editor, you can use Glue DataBrew's transformations as well. Therefore, it provides you a centralized view of both data preparation and pipeline orchestration. All right, I hope that makes sense to you. Now, let's talk about the difference in deep. The first service that we are going to see is AWS Glue Studio. So, what is the AWS Glue Studio? The purpose of Glue Studio is to design ETL workflow, right? So by definition, it is designed for creating and managing your ETL jobs, which involves moving data between different data sources and transforming it for various purposes. So you are designing an ETL, and then you are moving the data between different data sources and transforming it for various purposes. So it can be multiple different sources, it can be whatever the transformations that you want, and you can load it to different places. So that is the key role of your AWS Glue Studio. Okay, fine. So what is the users then? So what is the role of the users who mainly use this Glue Studio? This Glue Studio is mainly used by data engineers to build and orchestrate complex data workflows. But if you generally ask me, would a data engineer use more of AWS Glue Studio or AWS Glue Job Editor, I mean the script editor? As a data engineer and as an industry norm or an industry professional, we prefer to use the coding. Okay, so we prefer to use the Glue Job sc- script editor. Okay, we use a script editor rather than the visual editor. Okay, why is that? Because data engineers, we have to have more control of our data. We need to know what we are doing with our data. We must be able to tweak here and then, and this is very easy when you do it with your code, only if you understand the code. But there are data engineers. I'm not just making it broad, but there are people with different companies who don't want you to use much of a code, but as long as you get the job done, they are pretty much happy. And in those kind of scenarios and places, people tend to use uh, uh, AWS Glue Studio to orchestrate the data workflow. All right. Okay. Talking about the features. The features include a visual job editor for designing ETL pipeline. Okay, so you all know about it, right? Your Glue Studio is always going to have a visual job editor where you drag and drop the different transformations, and then you map them together to create your final ETL job. Then it supports for monitoring job performance and handling job dependencies. So AWS Glue Studio provides you support to monitor your job performance and handling job dependencies. So if you need to do benchmarking, okay, let's say you want to use different technology and you want to do a proof of concept. Yes, you can use Glue Studio because it comes with the monitoring of your job performance. Therefore, within Glue Studio, you have Glue logs, you have CloudWatch logs. So all these will pretty much give you information of what's happening with your ETL job. Your Glue Studio can generate Python scripts from visual designs. So whatever the visual transformations that you have created, so whatever the visual pipeline that you have created, whatever the visual design that you have in your visual job editor, you'll be able to generate the Python script. Okay, so because while designing your pipeline in your Glue Studio, you'll be defining uh, your source, you'll be defining your target, and then you'll be doing all the transformations with it. So when you try, if you want it in a code format, your AWS Glue Studio itself is able to generate the Python script for you. Okay. Your Glue Studio can integrate with the DataBrew's visual transformation while designing its ETL workflow as well. I'll explain how that works, but we'll pretty much keep it to the last. First, we'll know the differences here. And now, talking about the AWS Glue Data Brew. The purpose of using AWS Glue Data Brew is to it is a no-code tool that is used for data preparation. Okay, so if you're preparing your data, and for example, let's say you want to feed the data to your analytical model or machine learning model, predictive model, whatever it is, you are just feeding your data, right? What if you need to prepare your data? So yes, you are providing these data to different use case scenarios, I understand, but what if you need to clean the data? So that is when the Glue Data Brew comes into play, and it comes up with no code feature. So you don't have to write the code to clean your data. All you have to do is click and then create your recipes, which means nothing but a sequence of transformations. So you create all that and then you prepare your data. The Glue Data Brew enables users to profile, clean, and normalize data for analytics and machine learning. So Glue Data Brew helps you to clean your data. And what do I mean by profiling the data? So what it means by profiling your data is like getting summary of your data. It's like getting the summary statistics of your data, understanding your source and your target definitions, understanding the columns, what is the relationship between each of them, understanding number of rows, how many null values are present within the columns. So that is what you mean by data profiling. So your Glue Data Brew helps you to profile, clean, and normalize data, especially for analytics and machine learning purpose. And here it's pretty much to understand who the users are. Okay, it doesn't mean that data engineers don't use it, but data engineers are more into coding, more into cleaning, and more into standardizing the data with the code format, or they can use AWS Glue Studio of their choice. And now for Glue Data Brew, it is mainly to do with data analyst and data scientist. And here is why they have to use the Glue Data Brew. Because what if they need to prepare the data quickly? What if they want to prepare the data for their analytical model and their, even let's say, a machine learning model? It is not always good to be dependent on a data engineer, right? What if a data engineer is busy with some other projects that he is working on? What if your data engineer is working with a different client? So you cannot always rely on a data engineer, right? For analytical model and your machine learning model, the data analyst and data scientist can create or prepare their own data by themselves. Now let's talk about the features. An extensive library of over 250 pre-built no-code transformation for data manipulation. So your Glue Data Brew comes up with 250 pre-built no-code transformations. So to create your recipes, you can use these libraries, and then you can manipulate your data of by your choice. Interactive visual interface for building recipes. So how do you create your recipes? So you create your recipes by a visual interface. Okay. So through your visual interface, you create your recipe, and recipes are nothing but a sequence of data transformation steps. Data profiling capabilities including data distribution and anomaly detection. So using Glue Data Brew, which is, why do you use Glue Data Brew in first place? You're trying to prepare your data. And while preparing your data, you also can do the additional features, okay, like data profiling. So while you do the data profiling, you'll be able to understand, how is the data distributed, what are the rows, how many rows are present, what are the columns present, how are these columns related to each other, and what is the pattern of the data, Is there is any anomaly that can be detected? Is there is any pattern that is quite different to how the data looks usually? So all these kind of use case scenarios you can go in for Glue DataBrew. Glue DataBrew supports automating tasks like changing date formats, filtering invalid values, and correcting missing values. So once you create the recipes in your Glue DataBrew, okay, you have all these recipes in your interface, okay, or in your console. Whenever you have new kind of data, or let's say even the same data, or even data from the same source, whatever you wanna have it. When you use the recipe, okay, when you connect or map these recipes to the particular use case scenario, it will automatically support for your data cleaning. Okay, you don't have to do everything every time manually. So if you do it once, your further data pipeline data flow can be easily cleaned, which includes certain data preparations like changing your data formats, changing your date format, filtering your invalid values, and correcting missing values. Now, here is the key difference and integration that we must discuss about. Okay, the focus of using the Glue Studio, okay, and the key focus of using a Glue Data Brew. It's a bit different, though they are used in the same enrichment of data or a pipeline construction, whatever. They can be used in it, but they serve a different purpose. And the focus is that Glue Studio focuses on your overall ETL job and pipeline architecture, while Data Brew is focused on the detailed steps of data preparation. So when you need to prepare your data, you go for your Data Brew, and when you prefer to construct your ETL job and start your pipeline architecture, then you always rely on AWS Glue Studio. And talking about the user experience, DataBrew offers a highly interactive point and click experience for data cleaning, while Glue Studio provides a broader environment for designing and managing the ETL process. So, we understand that both of our DataBrew and Glue Studio, they are they provide us with a visual interface, right? But still, DataBrew offers a highly interactive point and click experience for data cleaning. Okay, both are using visual interface. Yes, we are right, but still, a more interactive and the better point and click experience is provided by your Glue Data Brew, whereas Glue Studio provides a broader environment for designing and managing the entire ETL process. And you must note that why is Glue Studio not up to that level of Data Brew? The reason is pretty much very simple. In Glue Data Brew, all you are planning to do is clean your data, right? You're just preparing your data. That's it. But in your Glue Studio, you're constructing an entire ETL pipeline. So that makes the difference here. Okay, because you're going to have multiple source definitions, the target, the transformations that you're doing. So it is going to be a bit complex and chunky, right? So you're not going to get a more better visual experience. Integration. The reason integration allows you to leverage DataBrew's powerful data cleaning recipes directly within your Glue Studio ETL jobs, combining the best of both tools into a single unified visual workflow. What if I need to use both the tools? And what if I say you, yes, you have the option to do it? So all you have to do is in your Glue Studio, you just use the DataBrew's cleaning recipes that you have created, right? So for all your data preparation on cleaning, you use recipes, right? Which are nothing but a sequence of transformations. So you can use the DataBrew's recipes into your Glue Studio ETL jobs as well. So therefore, you are combining the best of both the services. All right? Okay, fine. Now to our next question. Explain how AWS Glue utilizes Apache Spark and how this relationship impacts performance and optimization strategies within Glue jobs. Okay? So, we all know that AWS Glue uses Apache Spark, isn't it? So, under the hood, we have Apache Spark, isn't it? To distribute all your workload and then process it, right? So, though Apache Spark is an open source, in here they have Apache Spark, but AWS Glue being the proprietary service to your Amazon cloud, they still manage to use the Apache Spark under them. Okay, and now let's talk about how the relationship, okay, like the Glue, Glue is utilizing Apache Spark, and how is this relationship impacting the performance and optimization strategies within Glue jobs. Okay, so you are designing a Glue job which is going to do which is going to be utilized by your AWS Glue. Straightforward. But under the hood, we know that there is a Spark, Apache Spark. Now we will talk how this is impacting the performance and optimization strategy of Glue job. Okay, fine. AWS Glue is a serverless data integration service that extensively utilizes Apache Spark as its distributed processing engine for ETL jobs. This integration allows Glue to handle large scale data processing and transformations efficiently. So, AWS Glue is a serverless managed data integration service which we all know about. And this AWS Glue is going to use Apache Spark as its distributed processing engine. So, what is the role of a distributed processing engine or Apache Spark? So, when you want to process a data, your data is passed on to different executors, and therefore your data is split there and you're achieving parallelism while also not compromising the performance, right? So, similarly, because Glue is using Apache Spark, you can expect the same distributed processing as well. And because you can integrate both your Glue and Apache Spark, all your data processing and transformations can be done efficiently. Now let's see how Glue is using the Apache Spark. The first thing I would like to discuss is distributed processing. Okay, we all know that an Apache Spark does that. So Glue jobs, particularly ETL jobs, are executed on a managed Apache Spark environment. This means Spark handles the distribution of data processing tasks across multiple worker nodes, enabling parallel execution and significantly faster processing of larger data sets. So, when you say that you are running a Glue job, what are you doing? So, you're actually executing a Spark job, okay? Which means that all your Glue job or the Glue data distribution is under the hood getting handled by all your Spark worker nodes. Therefore, the more in a way that the data gets sent to different executors, you'll be able to achieve a better data parallel execution. Okay, so all your execution happens in one go because your data is distributed to different execution engines, and therefore because your data is using a parallelism, or your data is getting sent to different executor node, you'll be able to achieve a faster processing of your larger data sets. Fine. And then you have serverless execution. What is a serverless execution? Does it mean that there is no server at all? What does it mean actually? Does it mean that you're going to do a certain functionality without using any server? What does it mean actually? It's called a serverless execution, not because it doesn't use a server. Okay? Under the hood, you are getting servers in place. Okay? So all your job is going to be run by all this. But it is called a serverless because it is a managed service from your cloud provider, and all you do is you work on just the logics. Okay? So I'll repeat that again. Serverless doesn't mean that it's an absence of server, but serverless execution just means that your pipeline is getting processed, but with these servers under the hood. So you're not going to, physically provide any infrastructure. You're not going to provision any resources, or you're not going to maintain the network bandwidth. You're not going to work on the fixing patches. You're not going to work on those kind of scenarios or those kind of hardware level. So these will be handled by your AWS Glue. Okay, by definition, while Glue leverages Spark's capabilities, users do not directly manage Spark clusters. Okay, this is what I meant. You're not going to directly manage any of your Spark clusters. All will be managed by your cloud provider, and you just work on the logics. AWS Glue provisions, scales, and decommissions the underlying Spark resources automatically based on the job's requirements, providing a serverless experience. So, though Glue uses, while Glue uses the Spark capabilities, we do not directly work on any of the Spark clusters. So, Spark cluster or Glue cluster, nothing. So, when you use AWS Glue, you're not going to, uh, you know, provision any kind of these kind of resources. So, these will be automatically handled by your Glue itself. When you provision your resources in Glue, your Glue will manage it rather than you doing anything about it. PySpark for scripting. Glue jobs are typically written in Python using the PySpark API, which allows developers to interact with Spark's functionalities. This includes defining data transformations, reading from and writing to various data sources, and leveraging Spark's SQL for data manipulation. So, when we write a script in our Glue, what languages do we use? Please do not say English. I'm talking about the programming language. We typically use Scala or Python, right? And if you ask me which is the most prominent one, yes, Python is the most prominently used one. So you're using Python, and also on top of your Python, you can use PySpark API. What do I mean by PySpark API? So PySpark APIs are nothing but a combination, right? And then your Spark's capabilities are taken into account by using your Python code, right? So Python language, but you're using the Spark's API, which you call as Spark API, to uh, you know to script and transform or whatever the use cases. And therefore, we also can take the functionalities of a Spark. So why is that? Under the hood, it is a Spark engine. And on top of that, because you're writing in your Glue script, that doesn't mean that you will not be able to use all the Spark's capabilities or your uh, Spark API's functionalities. So while you write your scripting in PySpark, you will be able to define your data transformations. You'll be able to read and write from various data sources as you do in your usual Spark, Apache Spark, right? And also you can leverage the Spark SQL for your data manipulation as well. Then you have data catalog integration. So Glue's data catalog integration, using that, you which acts as a centralized metadata repository. So when Glue crawlers crawl through your data store, they'll be able to fetch the information of your data, right? The metadata. So all these metadata automatically get stored in where? It gets stored in your Glue data catalog, right? So this can easily integrate with your metadata repository as well. And from this, by leveraging Spark and your Glue data catalog, what you can do further? So Spark jobs can now easily discover and access the metadata about the data sources, the schema, the table definition that is being stored in your data catalog, right? And next, impact on performance and optimization strategies. So now we saw that how Glue utilizes the Spark under hood. Now we will talk about the performance and optimization strategies that is in place. The Spark-centric nature of AWS Glue job provides direct influence on performance and optimization strategies. Now let's talk about the performance and optimization strategies in place. First off, I would like to talk about the scalability. Spark's distributed architecture allows Glue jobs to scale horizontally by adding more worker nodes, enabling efficient processing of ever-growing data sets. So, what does a Spark do? Spark is a distributed architecture. Therefore, to process the data, your data gets distributed to various executor nodes. So, similarly, when you use Glue jobs, what happens is that you will be able to scale all your resources horizontally. And what do you mean by horizontally? In horizontally, you will add more worker nodes. And if I'm saying it as vertical, so for my single compute resource, its specifications can be improved. For example, let's say I have an 8 GB laptop and now I want to upgrade it to 16 GB. So that is an vertical scaling. What if I already have a 8 GB laptop, 8 GB RAM laptop, and now I need one more laptop that is of an 8 GB? So I've got two laptops with the same processing speed. So that is an horizontal scaling. So by horizontally adding more worker nodes, you will be able to efficiently process your data. In-memory processing. So Spark is an in-memory processing engine, right? So Spark's ability to perform in-memory computations significantly boosts performance for iterative algorithms and complex transformations, as it reduces reliance on disk input and output. So in Spark, what do? You do in-memory processing. And what is the benefit of using in-memory processing? When you do in-memory processing, your transformations are quick and the performance is efficient as well. Why is that? Because you're not going to put your data again to the disk, right? If you're writing the data to the disk, you have to perform a lot of reads and writes, which is nothing but input and output activity. But because Glue is using Apache Spark under hood, your in-memory processing therefore boosts your performance and your reliance on a proper speed as well, right? Okay. Now let's talk about the optimization strategies. First off, we have resource allocation. Optimizing the number and type of Glue worker nodes and the executor memory and cores within the Spark configuration is crucial for performance tuning. Okay. Now what's my goal? I need to optimize my Glue pipeline job. And now, how do I go with the resource allocation? So when you specify the number and type of the glue worker node, okay, and you'll be able to define the uh, specification of your executor memory and the number of cores, okay, within the Spark configuration. Therefore you'll be able to increase your performance. And of next you have data partitioning and shuffling. Spark supports partitioning and shuffling, right? So therefore now you can efficiently partition your data, and by data partitioning you can minimize the shuffling between the executors. So what do I mean by data shuffling between the executors? So in distributed processing, your data is going to be what? It's going to be distributed across the different executors. And now if I have done the partitioning already, when the data goes to the executors, only the relevant data goes to the particular executors. So therefore, you are minimizing the data shuffling operations, because all your one partition data, okay, will be going to one executor, one particular executor. So you are avoiding any movement of data between different nodes, and this is an key to reducing the execution time and resource consumption. Then the code optimization, which is very crucial because code must be optimized. So though there are multiple different strategies and resource allocation, the user interface mode for your pipeline jobs and everything, but at the end of the day, what is going to be run? Your glue script is going to get run. So when you write your glue script, make sure that you're writing an efficient PySpark code. And how to write an efficient PySpark code? You can minimize the use of UDF, and you can start to use Spark's optimized functions and data frame API, which can improve the performance. Then always try to use the latest Glue versions. Why is that? It's very simple. Why do you go for always the latest version of Android or Apple software in your mobile? Because you need to have improved performance, you'll be having improved security features, you'll be having more additional features in place. Your UI would have gotten improvements. So a lot of these kind of stuff, right? So similarly, even while using Glue, you can use the latest Glue version. Therefore it provides you with performance enhancements, and it also allows you to access the new Spark features. File grouping. Grouping smaller files together before processing can reduce overhead on the Spark driver and simplify task orchestration. So, this is a very common scenario where you will be getting lot of smaller files together. And what you can do is, because processing a smaller file is not an efficient way, so what you can do is you can group all the smaller files together, okay, before processing. And then because you're grouping them all together, you are reducing the overhead on the Spark driver, and also you're simplifying the task orchestration, right? And to our third question, what are the key factors that influence the cost and performance of an AWS Glue job? Let's say there is a company where they are defining your AWS Glue job. Do you think actually the cost and performance are interrelated? You can drop your answers in the comment section. Do you think the performance and the cost are interrelated? Oh, well said, well said. Yes, they are, interrelated in first place. How is that? Let's say I'm using an Android phone. And let's say I'm having a mobile phone that has like 4 GB of processor and 64 GB of storage. And let's say the cost is 10,000. What if I need to have a better version? What if I need an Android phone that has more features in it? So, if you have to use more features, if you have to use more kind of walking freedom, whatever it is from that house, isn't it? So, your cost and performance is interrelated, right? So, the more amount I put on my mobile phone, I'll be able to get a better phone with more processor and the more storage, right? So, just for a normal Android phone, if we would talk all these, the businesses, what would they think of? They would always think to save the money on the performance. Okay, I think I gave you enough time to think about the cost and performance. Now let's talk about the key factors. Okay, the key factors that influence the AWS Glue job is the resource allocation, the worker type, the executor type. What is the job script efficiency? Is it a good PySpark efficient code? As the optimization best practices are being followed? What is the data getting handled? What is the type of it? What is the format of it? What is the compression on it? Has the job Glue job bookmark been enabled? And other job configurations like the timeouts, the auto scaling features, are they enabled? So these kind of several factors can influence both the cost and your performance, okay, parallelly. So to balance the cost and the performance, what you can do, you can keep the right amount of resources, you can optimize the ETL script, you can use efficient data formats, you can enable auto scaling for dynamic adjustments, you can set appropriate job timeouts, you can leverage features like job bookmarks for efficient incremental data processing. Now let's talk about the factors affecting the cost and performance in detail. First one I have resource allocation, DPUs and worker time. What do I mean by DPUs? DPUs are nothing but a combinational word of multiple factors. Okay, so DPU stands for data processing per unit. Okay, data processing unit. So, what are the factors that impact your DPU? So, your DPU depends on compute, the storage, the networking. So, all these comes under your DPU. Okay, so anything, any compute, anything that is being used to uh, improve the to make your job run. Okay, those are your DPUs. Okay, so instead of charging your compute separately, instead of charging your storage separately, all these are a combinational terms and it is called as DPU. Okay, fine. Now, increasing your DPU or selecting a more powerful worker type can significantly boost your job performance and also increase the cost. Why is that? As I said earlier, if I'm, for example, if I go for a latest Android phone with more features, would it cost higher or would it cost lower? The question is very simple. It would cost higher, all right? So always try to keep account in your mind that while the resource allocated has been increased, the performance is also getting increased, also your cost is also getting increased. So it's never going to be the same. Then the job script, the quality and optimization of the ETL job using ETL script using PySpark or Scala directly impacts the performance and execution time, affecting both the speed and the cost. Okay, so the quality and optimization of your ETL script. So when you write your ETL script, make sure you write it very efficiently. Okay, you need to write it in an efficient way, that you use the right amount of resources, you enable right amount of executors, you enable the right kind of transformations, you are not having too much of data shuffling between the nodes. You write your transformations, and then you call the actions separately. So all these comes under your ETL script, so make sure that you write it properly, because it directly impacts the performance and execution time. Okay, now let's talk about the data handling. Okay, how do they impact it? Data source and sync performance. The speed at which data is read from and written to external sources and syncs can affect your job throughput. So, if your data is going to be stored somewhere, so when you read it, what is the speed it is being read on? So, the more the speed at which the data is read and written to from a different source will affect your job throughputs. Okay, data format and compression. Using optimized data formats like Parquet or ORC, and enabling compression can reduce the amount of data to process, improving performance and lowering cost. If you are using JSON, CSV, and these kind of file formats, your storage cost, your performance, the ability to read the file faster, it's all going to be impacted. So always choose the data format and compression that would increase the performance and at the same time lower the cost. Okay, so talking about the optimized data format, always try to choose Parquet or optimized row columnar format, and therefore you can enable compression and reduce the amount of data to process, improving performance and lowering cost. Job bookmarks. So in your Glue, you have something called as job bookmarks. Why do you use it? You use Glue job bookmarks, which allows you to track processed data, ensuring only new data is processed in subsequent runs, which reduces read times and costs. Okay, so when if you need to track your process data, it is a hard thing, right? You have to write separate script for your incremental loading, you have to include timestamps, all these kind of sorts. But I mean, you can do that, no one is restricting you. But one better way is to use Glue job bookmarks. Therefore, you never need to process your data that has been processed already, because Glue keeps track of all your processed data, and therefore if the data is already processed, you're not going to process it. So when the next job runs, the previous data that has been processed is left out, and only the new data is processed, therefore saving your time and your cost. And of next, you have job configuration. So talking about job configuration, you can the first thing I would like to talk about is auto scaling. So what is scaling? So in scaling, you have something called as scaling up and scaling down. Okay, so talking about scaling up, you will increase your resources. Okay, and scaling down is you will decrease your resources. Okay, so that is pretty much your data. I mean, that is pretty much your scaling up and your scaling down. So if you enable auto scaling, this feature will automatically adjust the allocated capacity for both the job, therefore dynamically adjusting the resources for cost efficiency and performance. Why is this good? This is good because what if you have purchased lot of resources, and what if you don't use it? So you're wasting money on your provisioning, right? So have auto scaling in place. Therefore, whenever your job needs more resources, your resources can scale up, and whenever you don't need it, your resources can scale down at ease. Therefore, you are saving your cost and also increasing the performance when needed. And then you have timeout period. Setting an appropriate job timeout prevents runaway processes, limiting potential costs from jobs that run longer than necessary. So when you set a proper job timeout, so what is a timeout? So when you write your exam, you have something called as timeout, right? So if your exam is for 3 hours, if you pass anything out of it, it's a timeout. You're out of time and you're not going, and they'll collect your papers from you. So that is what is more likely in your glue context as well. So make sure that you set appropriate timeouts. So if you set, for example, the job should run for like 10 minutes. So if the job is taking more than 10 minutes, your glue job just stops straight away. Okay, it doesn't hold up. It just doesn't process, because see, for less number of data, if you're processing to larger time, then there is some problem with your glue job. So therefore, having timeouts can prevent extra provisioning and processing the unwanted failure status jobs. And then always upgrade to your glue latest version, which will provide you with improved performance and access to new features. Therefore, you have better optimizations in place as well. All right. So these are the things that you need to keep in mind to optimize your cost and performance. And I believe you understood how they are related to each other and how they impact the performance as well. And if you like this video, do give a thumbs up. And if you have any doubts, feel free to drop your questions in the comment section. I'll be more than happy to address them. If not me, either my colleagues, they'll be able to help you with this as well. Okay. Before we end, who are we? We are Data Valley, the fastest growing edtech company of 2025. And we offer you with IT solutions, trainings, and placement support. And we have our data centers in US, UK, and Hyderabad as well. So we have multiple data centers there, which you can uh, if you're someone closer to that region, you can reach out to our data centers. You can have a look at our company, and you can attend our training institutes. If you're somewhere closer to this, try to make most out of this. Okay. And also soon we are expanding to regions like Chennai, Kolkata, Karnataka, and Delhi as well. So do give your continued support. And before we sign off, I would like to congratulate you for your uh, data engineering preparations. Feel free to share it with your friends who are preparing for their interviews as well. So this would help them a lot. And until I see you next time, this is Franklin signing off. Good evening. Bye bye. Take care.